So what's important here is that you actually increased your population from here to here, but if we look at what happens to consumption per capita, well, during the bad period, you're all at subsistence by assumption, because we said that population is the minimum of the two, because you need 1 unit of food to survive. So in this case, during both this summer and this summer, everybody is barely surviving. There's more people, but they have the same standard of living during the summer. During the winter, when there is more food, well, there is more food, so these guys are still, getting more during the winter than they're getting more than subsistence. But actually, they're sharing the same amount of food across more people. So half the year you're just as worse off, and the other half of the year you're less well off. So in sum, though you have increase your population, thanks to nomadism, your standard of living actually went down. Okay. So now we're just going to have to discuss very quickly what storage does to this picture. So we start from the same graph, and we're now assuming that we start from this place here. So this is our endowment vector, and what we're going to say is that right now there is no possibility for storage, but let's say that there's free disposal. So what this means is that if this is feasible, then within this box at these 90-degree lines, so any vector which is strictly smaller than this vector, any location which is strictly lower in both periods, or actually any location which is weakly lower, because it could also be here, then you can also attain that, because you can just throw away food. Now, if instead we were able to store perfectly, then we would be able to find any location such as this one or this one, which is inside this 45-degree line, because this 45-degree line is what tells us that you can give away 1 unit of food during the summer, so you don't consume it because you store it, and you get it in the winter. So this is this is obviously going to be the efficient boundary, but in theory anything could be doable. And one thing that's interesting is that if we want to say that the storage technology is not perfect, so if we want to say that a fraction of anything you store gets consumed, then we would just have a line which is like this at less than a 45-degree angle, somewhere between here and here. And this line on the other side, it would not continue this way, it would actually go down over here. Of course, nobody would want to give away food during the scarce period in exchange for food during the good period, so this is what we're interested in. But you see that if you're not moving, then it really doesn't make sense to not store if there is any, if it's at all useful, because of course, even if this was slightly larger than 0, the parameter controlling what you get for 1 unit that you store, if it was even slightly greater than 0, you would immediately get more population by trading food over here, this amount of food specifically, to gain this amount of food, because your population would be higher. Now, why isn't there always storage? Well, the reason is that if you're a nomad, you can't store, because if you're a nomad, you're always moving around, which means that you cannot store, because quite simply, well, the most efficient way of storing is body fat, because it's the most easy, it's the easiest thing to carry around is your own fat. It's easier than any backpack. And that is about 9 calories per gram, which is about 9,000 calories per kilo, which means that if you're putting up weight, you're also going to be carrying it, which means that you're going to be using more energy if you're always moving, and this severely limits your ability to store food, and you can't leave it behind you, because otherwise somebody might steal it from you. And so the point here is that you might be able to store to a certain extent. Here we're just going to combine these two. So you know this already, right? So we're here. We're in the valley right now, and we have to decide whether to become nomads or whether to remain settlers and to begin storing. And the way we're going to do this is that, as you can see here, this is the population you would have if you were a nomad. We've seen Y before. And this is the population with imperfect storage technology. So with this imperfect storage technology, you're not going to want to be a settler. You're going to want to be a nomad, because nomads have a higher population level. But if the storage technology increases beyond a certain point, you are going to jump over here. And as you do so, by storing, you're always decreasing your volatility. In fact, with the perfect storage technology, you can go to zero seasonality line, which is this 45-degree line passing through the origin. And what this means is that you have no seasonality, and therefore your standard of living decreases dramatically because you're always at subsistence level. And this would fit our earlier problem, which is what we started what we started from, which is why would somebody switch standard of living, although it's actually decreasing your average consumption, what you're eating and how you're living on average. Why would somebody pick a worse average? Well, because you're trying to avoid seasonality, because you don't want a population drop. So first of all, you're not maximizing average consumption. Average consumption is just an incidental, so to speak. And secondly, what you are maximizing is population size. And in pursuit of this, you accept whatever the consumption per capita happens to be, which maximizes this. If the transition is motivated not by a difference in expectation, but by desire to limit volatility, then you can actually have what we wanted, which is the idea that you change lifestyles, but actually your average consumption decreases.